Mm. Well, hello, folks. I think we'll go ahead and get started. It's good to see you all. Let me go ahead and open up in prayer, and I'll give you a sense of the things that we're going to be covering today. So, dear Heavenly Father, thank you very much for the chance to be working with each of the students in the course. I pray that the material will be clear, that it'll be motivational and enjoyable. And I'm also grateful for the students that they're wanting to get a chance to explore what the engineering profession is all about or technical computing. And I pray that this is going to be helpful for them to get a better perspective. Pray that you would help them in their spiritual formation, Lord, all the time that they're studying at APU, that they get a chance to be studying scripture, Lord. Give them greater insight into its meaning and the theological concepts we want to be deriving from that. In Jesus' precious name we pray. Amen. Well, it was nice to meet all of you guys on Tuesday, and I'm looking forward to continue to get some more perspective with you all, what it means to think of engineering and computing, which is the focal point for our course. I still don't have that much information about all of you, and your quote project proposals will give me a little bit of input to know the types of engineering, the things that you're interested in, that you'd like to develop, and I can start to tailor that in our conversation, the things that we get to explore together. So as a result, I think today I'm going to mostly focus on our textbook in our second chapter, and I'll get to that in a minute. And I think you'll see it's another part that maybe you may not have thought about, but this whole idea of planning is extremely important. I'm still pausing on the cover of our textbook just because it just shows you the variety of things where engineering and computing has its place in this ecosystem. If you think of various types of ways of generating electricity, maybe here just thinking of wind production, you could be thinking about solar production, the grid, the energy grid, biomedical application, aerospace. I talked a little bit about that, and I'll be
Hello,
showcasing some
testing.
examples about aerospace and NASA here and there. Whole types of different types of computing, building, urban planning, and it just goes on and on and on. There's just tons of things that we can see that we're going to get a chance to be exposed to. But for chapter two, it's going to be our focus for the majority of our time today. So we did an introduction to engineering profession, and we saw like trying to include not only the technical parts, but how we can do the betterment of life for a variety of individuals that may be in disadvantaged situations. And now in this chapter, we're going to be thinking about preparing for an engineering career. I know that we have a range of students, some that are freshmen, some that are sophomores, some that are juniors, and some that are seniors. And so that's a whole gambit of where you can be at in your engineering career or thinking about what you would want to be doing computer science or computer information systems. But let's just think about that. Ultimately, you all are going to school because you want to be getting a position that is interesting to you in a profession that you think is motivating. Some of you might find it interesting to work at NASA, Northrop Grumman, just to mention a few, where the sky's the limit in terms of the possibilities. So what are the objectives for this chapter? So first, it's making the transition from high school to college. And so this would be an example of something that's more focused for those that are freshmen. And I want to say just welcome. I know when I first got into college, it was a huge adjustment. I lived at home when I was in high school and then going to college, and I was living on campus. That was just a huge change. The idea that I had to be more disciplined in structuring my time. And so we're going to talk about that, recognizing the difference between high school and college learning, and realize that in high school, most of the learning took place in class, whereas in college, most of the education takes place outside of the classroom. So every one of you need to be devoting time outside of when you're in lectures to be getting to a point where you're mastering these subjects and really getting a chance to understand it. There's a term in Hidden Figures, a movie, if you've ever seen it, and he talks about looking beyond the numbers. So getting to a point where you can really embrace and see the bigger picture is important. We want to talk about budgeting your time, describe effective ways to manage your time so that you will be able to fulfill college, have a fulfilling college experience that includes adequate time for study, social events, and work, and also the spiritual part of that, being involved with chapel and other things where you can be nurturing your spiritual life as well. Want to be thinking about study habits and strategies. You want to find something that works for you, and it's not a one size fit all. There's different personalities and different temperaments. All of that plays in. What would be the time of day that's best for you? I can tell you that sometimes when I was involved in study groups and I was studying like complex subjects, that really helped. But it's what works for you. Some people are really good at doing things on their own, so figure that out. We'll get into explain study habits and strategies that lead to good academic performance. Getting involved in engineering organizations, there are a variety of ones that APU is trying to have you guys be aware of, and I can help out with some of those as well. Um, I, I am electrical engineer, so the Institute for Electrical and Electronic Engineers is one that I'm familiar with. SPIE, Society of Women Engineers, and COSE, that's a system engineering um, professional organization, engineering organization. And so describe why it is important to join an engineering organization. You want to be starting to establish your network now. And so who are folks that are doing what you would like to be doing, starting to be in touch with them, getting involved with LinkedIn. I'm on LinkedIn. I'm not on Handshake, but it's similar in this idea of starting to network professionally. And finally, thinking about your graduation plan, explain, and gets into explaining the importance of having a graduation plan. What courses are you going to take? When are you going to take them? Why are you taking those courses versus others? It's just this whole idea. This is near-term planning your school, but you really want to have a chance to be planning for your life. And all of that is important. And some of the work that we're doing in this course is trying to help you along that line. So let's first talk about this transition from high school to college. And so you now belong to an elite group of students that you are studying to be an engineer. 5% of bachelors of science graduates in the United States are engineers. I find that's surprising, but guess what? That's a rarefied environment and it's a very much in demand field. So either computer science or engineering. As a future engineer, you will be taught to look at your surrounding differently than other people do. Having that critical eye, creative way of thinking of how you would solve problems that you're observing. How would you quantify the things around you? Even the terms and the way that you do it are all stuff that we'll get a chance to get exposed to. You'll learn how to ask questions to find out how things are made, how things work, how to improve things, how to design something from scratch, and how to take an idea from paper to reality and actually build something. These are all the kind of things that happen in engineering and in computer related efforts. So why do you what you do for the next 4 or 5 years will affect you for the rest of your life. This is now you're getting to a more specific area. You've chosen a profession. And so you've made some decisions that are now leading you to a trajectory. And so how successful and happy you are will depend primarily on you. So you want this to be an enjoyable time, but also a mentally and spiritually and expanding experience. And all of that is possible with what you have available to you at APU. You want to be taking responsibility for your learning. In college, most of your education takes place out of the class. And so we mentioned that once before, but remember that. You want to have good study habits. You want to develop some new study habits and get rid of some of the old ones. It's not going to just be stuff that you're going to be getting in the classroom. And so you have to take more responsibility for your learning. So let's do a knowledge check here. Only a certain number of students who graduate with a BS degree from universities and colleges across the United States are engineers. Anybody want to venture a guess of what that is? You can put that in the chat or,
Five.
okay, yep. Everybody else agree with that? You can put a thumbs up as well. Any other reactions? Okay, good.
Five.
Yeah, so that's a rare environment. And partly it's due to this is not the easiest form of education that you can get, but it is extremely in demand, and so that's a good thing. So this is a source that they give for this. According to the Chronicle of Higher Education, approximately 5% of students who graduate with a BS degree from universities and colleges across the United States are engineers. So bravo, you guys are working in that direction. Well, let's think about time management. I don't know how much you've considered that. You can be thinking about this and maybe even actually coming up with a calendar, a weekly calendar of how you invest your time. So time is like money, and so you want to invest it wisely. Education is an expensive investment. It's responsible management is needed, and so learning is a lot of work. So it's not much fun in the beginning, but it can lead to joy and self-esteem. And so one of the things that I found that works for me is how can I make something that I have to do that may be a lot of work, maybe not quote the most enjoyable in one way. How can I turn it into something that's rewarding? How can I reward myself in many increments as I'm going through that process? Think about how you can be doing that, how you can reward yourself and keep yourself engaged. Learning and understanding new things can be downright exciting. That's one of the characteristics of an engineer. They like to see, observe, understand. All of those things are available to you. So here's an example, one way to be thinking about budgeting your time, and you could maybe look at this, but this is a good, healthy lifestyle. Getting 8 hours a day, that's a common number for folks. Maybe you might need a little more, a little less, but you just want to be starting to think about this. What about cooking and eating? I think a lot of you, if you're on campus, it may just be literally as going to the cafeteria. And so maybe this is not so much cooking, but eating and socializing, grocery shopping, especially for those that are off campus. Or maybe there's just some things that you're getting on your own that you want to make sure that you have to supplement your diet. Personal grooming, all of that takes a little bit of time. And so bookkeeping some of that, spending time with family and friends, relaxing, playing, sports, exercise, etc. And this just tries to give us about a 2 hour a day allotment for that. So that's about 100 hours a week that we're seeing, but there's still plenty of space there for us to be thinking about what we're going to be using in terms of our effort for study and stuff. So it may require a little bit of rebudgeting your time, depending on how many hours a week you need to work and to take care of yourself. Some of you may actually be working while you're actually going to school. That's going to make it harder and more of a requirement for you that you're going to need to budget your time. You want to make sure that you have enough time to take breaks between classes or study to refresh yourself. Maintain a daily logbook to keep track of how close you are to following your schedule and where time is being used inefficiently, and then modify your schedule accordingly. All of this is stuff that's useful to be thinking about. So how should you budget the remaining 68 hours of your day, of your week, I'm sorry. Let me just throw that out there and see if anyone has some thoughts about that. You can just go off mute, you can go on chat, whatever's most convenient for you. I'll show this next slide in case it helps, but I still would like to get your thoughts here. And so what it's recommending is spending at least 2 to 3 hours of studying each day of class time. So think of how many units you are. And so say if you have 16 hours, that means 48 hours that you would want to be investing in study. Some classes require more, some of them may require less. And even still, you still have 4 to 20 hours a week in your budget to allocate at your own discretion. So this just gives you an idea of how to be thinking about it. So maybe just have it people put in chat, or if you like, how many classes are you taking this semester? What's kind of the rough number that what people are taking?
6.
6? Wow, that's okay.
Aiming for 7.
Wow. So you guys are
6,
taking a lot, and it also depends like on how many units, if they're 3 units or less. Sal is taking 8, so God bless you guys. There is some advantage. I know that there's a range that you have like this flat fee that you pay. And so if you can manage to take more classes, it's actually a good return on your investment in terms of a monetary return. And so those are some things for you all to be thinking about. So think of your class schedule seriously. What is it that are your commitments? What you need to do to be taking care of yourself. You may have to be spending a little bit and then catching up in some areas when we have like Thanksgiving week or like next Monday you get a day off. So how can you start to help yourself out that way? Well, next about study habits and strategies. How are you going to keep yourself motivated, especially when you're having to do tough subjects that maybe you're not interested in? I had to take lots of physics and math courses in addition to my engineering courses. I'm sure you guys are all have had that experience or are having that experience. And some of it was quite interesting and others was not. It's like you may relate to one professor more than another. The textbook may be more appealing to you or not, or the type of the things that you have for assignments. And so just be thinking about that. But one of the ways that really can help you is attending your classes regularly. That's I can say as an instructor now, I can like to say on the other side of the podium, I really appreciate when people come to class. It's not only for you, but it just creates a richer learning experience for everybody. Be involved, ask questions, get what you need, and let's together have a great time getting through this materials. You can ask questions in class if you have read the material, made some notes about the concepts that you not fully understand. Those others useful. And you can keep that in mind. You want to be attending regularly so you're staying abreast of where things are at, and get help right away if you run into some challenges. All those are good advice. So when you need help, don't wait until the last minute to ask. The earlier you figure out there's an issue and you get it taken care of, it's going to make it easier for you. So the professor should have their office hours posted. And so I have office hours on Wednesday. I also am available via Zoom or phone call outside of that time when we can work out something that works best for you. If for some reason you cannot see your professor during the designated office, set an appointment. I'm happy to do that. So after you make an appointment, be on time. This is just a thing that you're going to be having in the business world, and have your questions readily available or written down so you can make sure that you get everything that you need. Take notes when you read the textbook and listen carefully during lectures. Those are things some people like to get hard textbooks and then you can actually write in your textbook. You can do that with electronic textbooks now. You can have your notebooks, whether wire bound or whatever, it would be preferable so you don't lose things. Study your notes at least an hour or two the same day you take them. It's fresh in your mind. Maybe there's a gap that you didn't write everything down, it was going too fast, and you can try and finish that. Make sure you understand all the concepts and ideas that were discussed in class before you attempt to do your homework assignment. So that review can actually be a good return on your investment of time. Write notes in the textbook margins while studying, that's helpful. And type a summary sheet of all important concepts and create an electronic file. Part of what I do with one of the assignments is you actually are going through each chapter and writing a summary in your own words. And so this is one of the ways I'm trying to reinforce that, the way that I've organized the material and the way that we do things in class. Make sure you have a good place to study. It's comfortable with good lighting, place that there's not a lot of distractions. Make sure that your roommates understand your study needs. It may not be the same as their, and keep your desk clean. All of these are some useful things to be thinking about. Your dorm room may or may not be the best place to study. You may want to be spending some time in the library, so you can keep that in mind as well. You form study groups. This is something that can be very helpful, especially if you have some challenging subjects. Study on your own first, and then get together with classmates to discuss and explain ideas and concepts with each other. Everyone in your study group should agree to come prepared to study appropriate material and contribute to the discussions. You want to explain ideas and concepts in your own words to others in the group. So if you're able to explain it in your own words, this is why it's really, when you're an instructor, you know the material that much better because you have to be making it understandable to others. So be an active learner, be involved, and not just a student. Use the term learner. So you're taking more responsibility for taking in that information and make sure that you understand that. In terms of preparing for examinations, there's no substitute for daily studying. You're trying to assimilate this information, and exams are trying to be one way that you can get better at taking that all in. You don't want to be waiting for the night before the exam. This should be used for review only. Also, you don't just want it in your short-term memory, you want it in your long-term memory. So going over it multiple times, not just the night before, you could actually have better assimilation and retention. You want to make sure you have a good night's rest. You don't want to have your fatigue be something that's going to make you not do as well on an exam. Beforehand, you want to be sure you understand the nature of what the exam is, how many questions, and what suggestions they have for your preparation. So for that, on that regard, all of the quiz material that you have, that is the example type of material, along with other things that will be on the final. But by getting to a point where you're mastering the concepts that you're seeing in the quizzes, that's going to be very helpful. So let's look at this. Your professor may offer additional something and discussion. So what do you think would be the best answer that you would think fill in that blank?
Instructions
Okay, instructions. Okay.
and explanations too.
Yeah, you can see that there's some, relatedness between explanations and instructions. So they chose to put explanations, and so your professor may offer additional explanations and discussions of some material that may not be well presented in your textbook. So you ask questions, you're getting more perspectives, and so we're trying to fill in the gaps. And if you're asking the question, chances are there's a lot of other people that have the question too, and so you're helping not only yourself but other people. And moreover, you can ask questions in class, and so take advantage of that. So get involved in an engineering organization. First of all, do a survey. What fits for you? What do you find that you're most interested in? So what are some common practices of professional engineering organizations? Conduct conferences and meetings to share new ideas and findings and research and developments. You as students, there's no reason why you can't be contributing to some of those conferences. Myself and other professors would be glad to come alongside you. Professor Chen brought one or more of her students in this last year, and so they were able to do things together. It was really wonderful. You can publish technical journals to help engineers in particular specialties keep up to date. And so this is a formal way of having a record of those developments. These professional organizations offer short courses on current technical developments to keep practicing engineers abreast of new developments in their respective fields. So in the future, that's something that you can be taking advantage of. They're able to advise the federal and state governments on technology-related public policies. Many of these organizations, they help in this policy development, and that's definitely the place of what the government is trying to do, is to enable industry to do its part and to have some kind of a structure of what is being aimed for in the society manner. They create, maintain, and distribute codes and standards that deal with correct engineering design practices to ensure public safety. All of those are things that are out there. They provide a networking mechanism, I mentioned this before, through which you can get to know people from different companies and institutions. So thus you have a pool of colleagues to help you solve problems. Um, when you're out of school, you're not going to have a professor or professors, plural, to help you. So this is a way that you can be helping out and get those resources. And you can help to look for good engineers to hire. Another great thing, you want to, in the beginning of your career, make yourself available and have these people find you. So I've talked about this, and now what are your thoughts? Anything that stick out in your mind, why you think it would be a good idea to join an engineering organization? Some of you folks that are juniors and seniors, this networking might be something that would be advantageous to you. But let me see if there's any other thoughts that people have.
You would be able to connect with more people who are like-minded like you, and also with the organization, you can get more of a guidance on what to work towards for.
Yeah, yeah. You can, all of that is very true. And just, kind of taking that a little bit further, what are the trends out in industry at large? This sector or subsector may be really taking off. Another one may not be at this moment. What are some areas that are getting quite hot? AI, Internet of Things. There's various things that are out there that really you want to be aware of. So all of those are helpful things. So these professional engineering associations give you access to industry publications and other resources, as well as opportunities for continuing education, including webinars, seminars, and courses that can inform you about important engineering trends. So we're thinking a little bit more in from a student perspective, and this answer is a little bit more from a professional engineer perspective. Okay, let's talk about your graduation plan. Have all of you met with your advisor? Do you have an idea of what you need to do to graduate on the date that you would like to graduate? And so maybe I'll just do a thumbs up, or how's that working for you guys? Are you guys getting
Nope.
mean? I think I heard a no. Is that true?
Yep.
Well, I think that's Andrew. And Andrew, I highly recommend that you should have an academic advisor. I don't know without looking at the enrollment to know where you at if you're a freshman, sophomore, junior, or senior. But this is something, in maybe a serendipity for taking this course. You're getting reminded now in the midst of taking a class to come up with your graduation plan. And so a couple of you said that you have been talking with your advisor, talking with Dr. McCoy. All of those are good things that you want to be doing. And so Andrew, please definitely take advantage of those individuals. And when you first came to APU, I'm pretty sure the ones that I've been helping out with it, advising, they get something early on, their degree plan of how to work it out. So please do take advantage of that. And if nothing else, talk to Dr. McCoy, and he can start to steer you in the right way, besides your academic advisor. So you know what the admissions are, you're here. Now the next things to be thinking about, if you wanted to get into grad school, well, what type of degree do you want in your master's? That would be the next step. So there may be some things that would, in terms of your electives, that they might be steering you in one direction or another as a result. If you're trying to graduate early, maybe it might mean you take a couple summer school classes. And so these are all the things that you want to be thinking about. I didn't set up it as an assignment in this course, but it'll be, you could actually do it for chapter 2 a little bit, is start to write up your graduation plan for a summary for this chapter. That's going to be up to you. So we're not in this situation. We don't have anybody here in a community college, but some of you may be in a situation where you've transferred. And so this may be something that you're going to have to work a little bit closer with your advisor, Dr. McCoy, to make sure that you get what you need so that you can graduate when you expect to graduate, and not be in a situation where you find that there was something lacking and you don't have a lot of time to figure out what it is and fix it. There's other things, doing volunteer work. Some of you may want to be thinking about doing a summer missions trip. I know that APU has things that they do along that line, or it may be with your church, or even just helping out at APU in one way or another. Maybe some of you would like to be doing some tutoring. There's always a need for that. We have an election coming up. And so being good, responsible citizens, all of those are things that we can be a part of. And so you can think about that. Get to know your classmates. There are opportunities that APU tries to help along that way, but you may find some that you have a special affinity with. You can be making some long-term friends. I have friends from high school and college that I've stayed in touch for a lot of my professional life and personal life, and it's been a very rewarding thing. So if you're an undergraduate, get to know some folks who are upper division, that maybe they can give you some suggestions about courses or strategies. All of that can be things that would be helpful for you. So what is the youngest age at which a citizen can vote? What do you guys think here? Yep, at least in California, but some of you may be from other states. The minimum age is 18 here. I'm not as familiar with other states, but I think in other places it is 21. It doesn't even list that here. I haven't heard of anything where there've been something that they've been trying to look at things getting down to 15. But anyway, some of you are eligible to vote. Actually, I think probably most, if not all of you, are older than 18. And so that's definitely a privilege that you can take advantage of. Well, that's all it is for this chapter. I'm not going to go into chapter 3, but let me first of all see if there's any comments or questions before I just think about a few other things that we have in Canvas and go with that. Okay, well, let me just flip over to Canvas, and I may play this video more than once. And as I get a little bit more information about where people have interest. Oh, there was one thing. Let me try this video that didn't work on Tuesday. I'm not exactly sure why it didn't work, but it might work now, so I'll give it a shot. So I'm just going to back up. We'll see. If not, it looks like somehow did the link wrong on this, and I'm not quite sure why. Okay, it didn't work. Sorry about that. But maybe if I just tried it again, it would get different results. Does it work like this? That's weird.
Hello, everyone. Welcome to today's video. Today, I'm going to talk all about what it's like to be a NASA engineer because, yes, as cool as that sounds, I would know. First of all, if you do not know me, my name is.
Oh, what happened?
Hello, everyone. Welcome to today's video. Today, I'm going to talk all about what it's like to be a NASA engineer because, yes, as cool as that sounds, I would know. First of all, if you do not know me, my name is Pat. I am an electrical engineer and have been an electrical engineer for the space industry for the past few years. I started my career at NASA's Jet Propulsion Lab as an intern, where I was extended 3 times before finally being offered a full-time position about 6 or 7 months before my actual graduation date. If you're interested on how I got my internship, I did make a video about that. That is the first one in this 3-part series. And if you're interested on how I was able to turn that internship into a full-time job, I also made a video about that. So you can find that right here. And I'll also link them down in the description. So I first started out my career working for several different missions. I didn't really have a set mission that I was a part of. I was kind of jumping around while I was an intern. So I've been able to work on missions like the Perseverance rover and Psyche in that way by filling in for others. But when I became a full-time engineer, I was officially assigned to the Europa Clipper mission. If you don't know what the Europa Clipper mission is, let me tell you, because it is one of the coolest things I've ever done in my entire life. So the Europa Clipper mission is an orbiter that is going to go to Jupiter in order to do an investigation of its moon, Europa. Europa is really, really cool because it is the biggest possibility for suitable conditions for harboring life. Now, another really cool thing about this mission is that even though it is going to go and investigate Europa, this orbiter is going to be orbiting Jupiter. It has some really cool instruments like a radar capable of penetrating ice because we want to know how thick that sheet of ice is around the moon, because Europa is also believed to have liquid water beneath the icy crust. So finding out how thick that ice layer is and where the water is definitely one of the major goals of this mission. But I digress. As you can tell, I'm very excited about this mission. Europa Clipper was my very first full-time NASA mission, meaning I was officially assigned to this mission on a full-time basis. The group that I was in, you can think of it kind of like a puzzle piece, where this group, no matter the mission, will always do this particular part. And so a lot of us, even though we're in the same group, we're split up into the different missions doing similar work. So like I mentioned in the previous videos, I started out my career as a circuit board designer and PCB designer. So I was working on so many really cool things, designing circuit boards, and this continued into my full-time job. My latest design actually was for the Mars sample return mission, something that's actually going to be on the actual spacecraft. So when I joined Europa Clipper, I got a taste of what it's like to be a test engineer, because when I joined, a lot of the different systems and boards had already been designed or chosen. We were in the testing phase, and this is something that's very common at NASA, where you can follow your project through the different stages. And I really love that about working for NASA as opposed to maybe a larger company. Now, I just want to say real quick, this does depend on the group that you're in at NASA. For example, if you're working on designing a spacecraft computer, then yes, you are going to have a lot more people kind of looking over your shoulder. You're likely maybe only going to have one particular role, and then another group is going to be doing the testing, another group is going to be doing assembly, things like that. So during this time, we were in the testing phase, which meant that I was doing a lot of testing of spacecraft simulations. The way that we test the spacecraft computers is by designing some really, really fun, really big, and really time-consuming simulations, which simulate the entire spacecraft. So picture like putting the computer in the matrix. The computer thinks I'm in the spacecraft, or it thinks I'm on my way to Jupiter, but really it's just in our lab connected to a bunch of our simulations that we design, build, and test. I eventually became the test lead for this particular group that I was in within Europa Clipper, where these systems and simulations were my responsibility. I would write the procedures for them. I would test them. I would direct anybody that was working with me on what we needed to do. And if anything wasn't working with it, I needed to fix it. But I will say that something that I really, truly love about working at a place like NASA is how friendly everyone is and how willing they are to teach you something. There were so many times where I would walk into some of my coworkers' offices who have been working at JPL for, so many years and had worked on so many amazing missions, had all this experience. I would go in there, ask them a question, and they would pull out their whiteboard and do an entire hour-long lecture to teach me about the way things have been done before, what has been tried, what worked, what didn't, why we're currently doing what we're doing. It kind of felt like your own personal university in a way, where your professors are the people that you have looked up to your entire life. Another thing that I really loved about working for NASA is that they were so willing to let you try something new. So if you were to go to your supervisor and say, I want to try some programming, or I want to try some board design, or I want to try some testing, they try to find a way and find some time for you to get in there and do those things. So your degree, you weren't bound to it. You didn't have to stick to that if you didn't want to. You could go out and explore and try different things and learn from the people who were currently doing those things at a very advanced and important level. Now, have I had moments where I felt like I didn't belong? I felt scared. I felt overwhelmed. Absolutely. But working at NASA has really taught me to value myself, value my work, and specifically working with the lead that I was working with really taught me to value my work-life balance and my personal life outside of work. Thank you so much again for watching. Feel free to subscribe. Feel free to follow me. All of my socials are right here.
Well, anyway, any questions on that? Did that help? Just give a little bit of a perspective, what it's like to become an engineer? Okay, good. I'll try and include things like that as I can find stuff for you that would be relevant. I think I'll save this. This is we have a couple of different types of tools that we can be using when we get into the medium part of our course. I'll just go back to our menu. So the engineering fundamentals, we're going to get into some of the physics, some of the computational tools. This is where we're going to be exploring spreadsheets, MATLAB, and Python. So those are some things that are commonly used. But we may dip into that a little bit early to help us get some perspective on some of these engineering and physics related fundamentals. So we'll see how that goes. Anybody have any more thoughts on what they'd like to do for their project that they'd like to share? Still trying to
By when do we have to decide?
well, let me look on the schedule again. So if you just go to the syllabus tab, I think I purposely made this early. So it's going to be next Thursday. So maybe next Tuesday, if at least we can have part of our course time that we can get some ideas that you can share. This is going to be helpful for me, not only as it's a first step for you and what you're going to be doing for your project, but it also gives me, now you've had to write it up and think about what you would like to focus on. What would you like to research? You saw in that video that she was able to try different things and get some insight into this or that. And so maybe there's an area of engineering or computing that you're interested in. Now you'll get a chance that you can be doing some research and write it up. Maybe you could be applying some engineering rigor. Maybe actually do a little bit of something in MATLAB or a spreadsheet or something like that to try and come up with some scenarios and see how it plays out. I taught an introduction to engineering course, and one of the students that was in the class, he was actually from Africa, and so he was trying to increase the capacity of their solar system and also the battery backups that they had. And so thus we were trying to get some perspective on, well, how many solar panels would you need? How many batteries? How would we go about coming up with a basis of estimate for what they would need to power a community center, to power a house, to power the community? And so this is in a place where there isn't a lot of power, and so you have to generate your own and then have the infrastructure that people could come over to this meeting place, plug in their devices, charge up their batteries, maybe download some information that they can then get on their devices and take it back to their locale. And so you can have like a center repository and spokes where all of that, they come in, they can have fellowship, you can be meeting the spiritual needs of these individuals, and then they can be going out. You know, the sky's the limit. I saw that Zaid said, I'm ready for NASA. I think NASA is a wonderful place to work. I have done some work for NASA, but I've never actually worked for NASA, but with their various partners. That I was one of those various partners I was able to work at. Did a little bit of, I've done some work for several NASA centers as well as NASA headquarters, and all of that has been really very rewarding. So Andrew said, why work with NASA when NASA can work with you? Okay, that's cool. So it's a nice way to be thinking about it. Any other comments or questions? Well, then I'll give you back some time. You can be working on some of the reading, doing some of the quizzes or chapter summaries, and definitely start to be thinking what it is that you find interesting that you would like to explore for your project work. And I'll look forward to be helping you guys out as you go along with that. Oh, I did have one of the other things I do have is this faith integration essay. Remember, we had talked about in our lecture about doing your degree planning. Well, one of the things I try and have people think about in their faith integration is not only thinking about now, but thinking of the future. So it's a result of you getting not only your technical degree, but exposure to biblical and theological concepts. How are you going to be able to integrate that in your future? What are some desires and how you might do that? We'll talk about that more, but I just wanted to mention that just since that came up as part of our lecture for today. Okay. All right. Well, God bless you all. Have a wonderful rest of your day, and I'll look forward to seeing you all next Tuesday. Take care.